Hi, in this tutorial I will give an overview of how you can use Raspberry Pi in combination with the MATLAB, and then I will focus on using the SPI and the I2C interfaces on the Raspberry Pi device. So this is the contents of this tutorial. We will use Raspberry Pi and we will use the MATLAB software. And then in order to use Raspberry Pi in combination with MATLAB, we will need to use the MATLAB support package for Raspberry Pi. So these topics are covered in more detail in a previous tutorial. So this tutorial will focus on how to use I2C and SPI on Raspberry Pi in combination with MATLAB. So I will give an overview of and demonstrate some basic examples. For the I2C, I will use a TC74 temperature sensor. For the SPI, I will use an analog to digital converter called MCP 3002, and I will also use a temp36 temperature sensor in combination with this this analog to digital converter. So let's start with the Raspberry Pi. Here you see an overview of the Raspberry Pi hardware. So part of this MATLAB support package for Raspberry Pi, you are installing an operating system on this SD card that you use in combination with the MATLAB software on your personal computer. And in this tutorial we will use these general purpose input-output pins where we can connect different sensors like this TC74 temperature sensor and this analog to digital converter and also this temp36 temperature sensor. Raspberry Pi doesn't have any analog out or analog in, so it's pure digital pins. And also we have these I2C and SPI interfaces. So in this tutorial we will use the MATLAB programming environment. So here you see an overview of the MATLAB programming environment. So MATLAB is a very powerful tools for mathematics, solving linear equations, modeling, simulation and control applications, etc. So in order to use MATLAB in combination with the Raspberry Pi hardware, you need to install and use a package called MATLAB support package for Raspberry Pi. So typically you have your desktop computer or your laptop computer with MATLAB installed, and then you have this Raspberry Pi somewhere on the internet or on your local network. So on this so you basically create the MATLAB applications here on your personal computer, and then by using this MATLAB support package for Raspberry Pi, these packages are downloaded and are executed on the Raspberry Pi hardware. So basically this is how this MATLAB support package for Raspberry Pi is working. So basically then we have our MATLAB software installed on our computer, and then we have this Raspberry Pi device, and then these two devices are communicating through typically Wi-Fi, or of course you can also use Ethernet and an Ethernet cable to connect these two, connect the Raspberry Pi with your local computer. And then you use this Raspberry Pi and a general purpose input-output pin to connect different components, different sensors, etc. on these different pins, and then you create a proper program here in MATLAB in order to communicate with these pins and retrieve values from the different sensors, etc. And you can also use the MATLAB software for more analysis. We can retrieve lots of data from different types of sensors, and then we can analyze the data here in MATLAB, create charts, plots, etc. So basically before you start you need to install this MATLAB support package for Raspberry Pi within your MATLAB environment. So in the MATLAB environment you just go to the add-ons, and then this add-on explorer is popping up, and then you can just search for Raspberry Pi, and then this MATLAB support package for Raspberry Pi hardware will pop up, and then you just click on it and install it. And then you need to go through a set of steps in order to install the necessary software on the Raspberry Pi device. So you start by selecting the hardware type you are using. So in my case, I'm using a Raspberry Pi 4. Then click next, and then I want to connect to a wireless network. So then I set up a wireless network. I need to insert a micro SD card into my computer in order to install the necessary operating system on the Raspberry Pi. So I just put in a micro SD card, click refresh, and then click next, and then you just follow the wizard in order to install or set up this micro SD card. And when you're finished, you just take out the SD card from your computer and put it into the Raspberry Pi, and then you're good to go. And then hopefully when this software has been installed properly, you can go to MATLAB to test that you are connected to the Raspberry Pi. So then you can just type R equals to Raspberry, which is part of this MATLAB support package for Raspberry Pi. And then if you are connected to the Raspberry Pi from your computer, then you should get a response like this. Then you should get an overview of the IP address for the Raspberry Pi, port number, board name, available pins on the Raspberry Pi, etc. So basically now we're ready to start using and start programming and communicate with the Raspberry Pi hardware and the Raspberry Pi general purpose input-output pins. So before we start using this I2C and SPI interface on the Raspberry Pi device, let's take a short overview of the Raspberry Pi general purpose input-output pins. So here, as mentioned earlier, on the Raspberry Pi hardware, you have these pins called general purpose input-output pins. So here you have lots of pins that you can connect external components like LEDs, motors, connect different types of sensors like temperature sensors, external analog to digital converters, or external digital to analog converters, etc. So basically these general purpose input-output pins, we have lots of digital pins that we can use either as an output or input. We have pins for pulse width modulation, and we have those digital pins that we can use for digital communication using this I2C interface and the SPI interface. So here you see an overview of these I2C and SPI pins on the Raspberry Pi. So here is an overview of all the pins on the Raspberry Pi, and here you see the pins that are used for I2C communication, and here you see the pins here and here that are used for SPI communication. So let's start with I2C and how we can use I2C in combination with MATLAB, and to use I2C to communicate with the external components that are connected to the general purpose output pins on the Raspberry Pi hardware. So basically Raspberry Pi is a so-called I2C master, and then you can connect different I2C slaves and connect them to the Raspberry Pi and the general purpose input-output pins. And those I2C slaves can be analog to digital converters, digital to analog converters, different types of sensors, etc. And these components need to support this I2C interface. In order to use I2C on Raspberry Pi, you typically don't need to do anything, because the I2C bus or the I2C communication is by default enabled, so you don't need to do anything. But if you for some reason the I2C is not enabled, you can use the command enable I2C in order to enable this feature. But normally this is enabled by default. So here you see the I2C wiring on the Raspberry Pi. So you use these general purpose input output pins on the Raspberry Pi, and then you have these I2C pins on top here that you need to use in order to communicate through this I2C interface. Here you see an overview of the functions that you can use in order to communicate through this I2C interface. So these are the objects and functions that are part of this this package that you have installed, this MATLAB support package for Raspberry Pi. So typically we need to use this Raspberry object in order to start the connection to the Raspberry Pi board. Then you use this I2C dev in order to start the communication using this I2C interface, and then you have different functions. You can use scan I2C bus in order to get an overview of devices that are connected to the Raspberry Pi using this I2C interface. You have functions for reading data, writing data, read register data, write register data, and then you have also this enable I2C and disable I2C if those are needed. So by typing this or using this object Raspberry, you will get an overview of the pins and other stuff related to the Raspberry Pi that is connected to your computer. But in this case, we need to know that here available I2C buses is it's one I2C bus available on the Raspberry Pi, and it has a specific name, I2C 1, like this. So this is the one that we are going to use in order to communicate with the I2C bus. So now I have opened my MATLAB environment. So let's see some of these commands in action. So then you can type this Raspberry like this. Sorry, I just put it here in the command window like this. Click enter, and then you see the MATLAB respond with this following information. You see I am now connected to my Raspberry Pi. It has this specific IP address, port number. I'm using a Raspberry Pi 4 Model B, and then we have these available pins here, and then you see this is the available I2C bus with the name I2C 1, like this. So this is the one that we are going to use in order to communicate with the I2C bus. You can also use a command called show pins like this. Oh, sorry, it should be on lower S like this. So show pins like this. Click enter, and then you see I get an overview of my Raspberry Pi and the connected pins. So here you get an overview of all the pins on these general purpose input output pins on the Raspberry Pi, and then we have these I2C pins that we need to use here. So basically this show pins is a good command to use in order to get an overview of all the pins on the Raspberry Pi. Next you can use a command called scan I2C bus in order to retrieve information regarding if you have any components supporting the I2C interface connected to the Raspberry Pi. So then I can type like this, use the object, and then typing the name of the bus, which is I2C 1, like this. Sorry, and then click just enter, and then you see here I get a list of available components that are connected to my Raspberry Pi, and in my case I have already connected this TC74 temperature sensor that are supporting the I2C interface, and then here you see the address for this specific component or the sensor in this case that are connected to my Raspberry Pi. So I need to use this address later when I'm going to communicate and retrieve data from this TC74 temperature sensor. So now let's see how we can use this TC74 temperature sensor that has an I2C interface, where we can communicate with this sensor from the MATLAB environment and retrieve data from this sensor. So here you see an overview of this TC74 temperature sensor. It looks like this. It has 1, 2, 3, 4, 5 pins, but you need to only use 4 of those pins. This first pin is not in use, so typically use this pin called SDA. Here's the ground pin, here's the clock pin, and here's the voltage in pin. So typically these are the 4 pins that you need to use in order to communicate with this sensor. So this temperature has a resolution of ±1 degrees Celsius. So the temperature sensor is not that accurate, but it's typically good enough for many purposes. So it stores this temperature value internally in a register within this chip on the temperature sensor, and then we can use the I2C bus in order to communicate and retrieve this temperature value from this sensor. So here you see an overview of how you can connect this temperature sensor through the general purpose input-output pin on the Raspberry Pi. So here you have the general purpose input-output pins that are available on the Raspberry Pi, and here you have the TC74 temperature sensor. So we use this SDA connected to pin number 3 on the Raspberry Pi. Then we have ground connected to one of the ground pins on the Raspberry Pi. Then we have the clock pin, which is connected to pin 4 or 5 on the Raspberry Pi, and then we need to connect power, and then you can use this 5 voltage pin, pin number 2 on the Raspberry Pi. So basically this is the wiring you need to use in order to be able to communicate with this sensor from a Raspberry Pi and the MATLAB environment. So it's a quite simple setup, and here you see I have already set up this sensor and connected it to my Raspberry Pi. So here we have these TC74 temperature sensors, and then I use these wires in order to establish the communication with the sensor and the pins on the Raspberry Pi. So then let's start with a simple MATLAB program in order to communicate with this sensor and retrieve the temperature value. So then we typically need to establish connection with the Raspberry Pi with this command. Then as shown previously, the address for this specific TC74 temperature sensor is this address, which we found earlier, and of course it's also written in the datasheet for this specific sensor. And then we need to establish connection to the sensor using this I2C dev command, where you have the RPI object created here, the name of this specific I2C interface on the Raspberry Pi, and then the address which is stated here. So now we have established connection to the sensor. Then we can use the read command in order to read values from this sensor. So we just, as an input to the read function, we need to have this device object which is created here, and then for this simple sensor we only need to read 1 byte, which is actually the temperature value that are stored on this device. So then we can retrieve the temperature value and put it into a variable called temperature or something, and then we can use the this function in order to display the temperature on the screen within the MATLAB environment. And a good practice at the end is to clear all objects like this device object, RPI object, etc. So let's copy this code into the MATLAB environment and see if we get any results. So then I'm back in my MATLAB environment. I'm using this editor now. So you find it here, you can click new in order to open a blank window here where I can just paste in my code. So this is the code in order to communicate with the TC74 temperature sensor and read the temperature value. And then I will display the temperature value on the screen. So then I just save this example. I just save it as TC74 example or something like this, and save it on my hard drive. And then I'm actually ready to just run this. I can just click the run button and then just wait a few seconds, and then you see it displays the actual temperature value that are present here in the room I'm sitting. So by creating this simple program, I'm able to communicate with the TC74 temperature sensor that are connected to my Raspberry Pi, and then I'm able to retrieve that value within my MATLAB program and display this temperature value on the screen like this. So this is the basic setup that you need to create in order to communicate with the sensor and retrieve the value. Now I can show a more advanced application where I'm using a loop, plotting the values, etc. So I already created this program. I just find it on my hard drive, open it, and then here you see this extended example. It's basically doing the same here as this example. Start the communication with the I2C device and present the value on the screen. But here I'm using a for loop in order to retrieve new temperature values, in this case every 2 seconds. So here I'm using a pause function, and then by doing this I'm retrieving a new value from the sensor every 2 seconds. And then these loops just go, you can, here it goes from 1 to n, and in this case n is 10, but of course you can change n to whatever you like. And then in addition to display the temperature to the screen, I'm also saving the temperature value into an array, and when the loop is finished I'm plotting these temperature values inside a plot within the MATLAB environment. So basically it's the same example as this one, but it's just extended with a for loop and a plotting functionality. So let's just run this example as well. So now it's initialization, so it presents a new temperature value here every 2 seconds, and then I can hold on the temperature sensor with my fingertips in order to change the value. So every 2 seconds it's presenting a new temperature value, and then when the loop is finished it is presenting these values inside this plot. So basically this is how you can create a simple program in MATLAB in order to communicate with an external I2C sensor that are connected to the Raspberry Pi remotely. So here you see the entire program for this application. So I start with a clear in order to clear all previous variables. I establish connection with the Raspberry Pi. I do some initialization, connect to the I2C device. I have some variables here. Here I have the for loop, and then here I have the plotting feature, and finally I just clear all the objects like this. So basically this is the entire MATLAB program for communicating with this I2C sensor, retrieving data and plotting them in a plot within the MATLAB environment like this. So next, let's see how we can use the SPI interface on the Raspberry Pi in order to communicate with the different components that are supporting this SPI interface. So SPI is short for Serial Peripheral Interface, and it's a very popular interface for communicating with different types of components like sensors, analog to digital converters, etc. that are supporting this SPI interface. So we have typically thousands of different components and sensors that are supporting this SPI interface. So here you see an overview of how the communication is working. So on the Raspberry Pi there is an SPI master that are communicating with an SPI slave, and for SPI communication we need to use 4 pins. So it's the serial clock pin, and the master out slave in, and the master in slave out pin, and also this CE or SS for slave select. So in order to communicate with an external component that are supporting this SPI interface, we need to use these 4 pins that are available on the general purpose input output pins on the Raspberry Pi. So here you see the Raspberry Pi and the general purpose input output pin connector, and then you see here we have these 4 pins that we need to use in order to establish connection with an external component supporting this SPI interface. So here you see an overview of the SPI commands that are supported by this Raspberry Pi package. So we have this standard Raspberry object that we need to use in order to establish connection to the Raspberry Pi board, and then we use this SPI dev in order to establish connection using this SPI interface, and then we have the SPI functions for write, read, enable SPI, disable SPI if those are needed, but typically those are enabled. So basically we need to use this one, and this one in order to communicate and write and read data from the external component that are supporting this SPI interface. In order to get an overview of the SPI channels that are available on the Raspberry Pi, we can use this available SPI channels feature. So by creating this simple program here using this Raspberry in order to establish connection to the Raspberry Pi, and then we can use this object rpi.available SPI channels, and then you will get a list or an array of available SPI channels on the Raspberry Pi, and we have 2 channels that we can use, either CE0 or CE1. So we have 2 channels that we can use on the Raspberry Pi. As you can see from this previous wiring diagram, we have this CE0 and then we have CE1, so you can use either of those, but the one we are using, we need to specify that in our MATLAB program. So here you see a basic example for communicating with an SPI component. Typically we want to both write and read data from this component, so then we establish connection with the Raspberry Pi using this command, and then we start communication with the SPI interface and specify the channel in this case, and then we can use this write read command in order to both write and read data from this specific component. So this is just a basic example. Further in this tutorial I will show how you can communicate with an analog to digital converter using this SPI interface. So now let's see how we can use an ADC with the SPI interface in combination with the Raspberry Pi and the MATLAB. So an ADC is an analog to digital converter. Because Raspberry Pi has only digital pins on the general purpose input output connector, and if you want to use analog components or analog sensors together with Raspberry Pi, you typically need to connect that device or component through an external analog to digital an ADC chip in order to convert the analog signal from the sensor to a digital signal that is used internally in the Raspberry Pi. So here you see typically an ADC chip. It typically has 8 legs like this. It can have also more legs, but the chip we are going to use in this tutorial has 8 legs like this, and then you typically just connect it through a breadboard and then use wires for the different pins to connect it to the Raspberry Pi. And there are lots of different analog to digital converter chips on the market today. I guess there are hundreds of different types. In this tutorial I will use an MCP 3008. It is an ADC chip with 2 channels, but there exist many other types with different types of resolution and different types number of channels. I guess basically they all work in the same manner. So if you don't have this specific chip, I guess this tutorial can also be used by other similar analog to digital chips. Here you see an overview of the pins on this MCP 3002 ADC chip. So it has 8 legs or pins like this. So these chips also use this SPI interface. So all these pins are needed to be used in order to communicate with the Raspberry Pi and the MATLAB software. So let's see how we can connect this chip to the general purpose input-output connector on the Raspberry Pi, and then let's see how we can create a MATLAB program in order to communicate with this chip and retrieve an analog value within the MATLAB environment. So here you see how we connect this MCP 3002 to the general purpose input-output connector on the Raspberry Pi. And so just wire this component according to this wiring diagram, and then you are ready to start using this MCP 3002 with the MATLAB software. So in order to test it in MATLAB, we can connect let's say a battery on this so this channel 0 and channel 1 is the 2 analog input channels that you can use on this this chip, and then this value, the voltage value you put here, will be read within the MATLAB software. So you can test it using a battery like this, or you can use a potentiometer, which I will use in this this example or in this tutorial. So then you can, instead of a battery, you can connect a potentiometer through these input channels, and then you can turn this knob on top here. So when it's on minimum, it should show 0 voltage within the MATLAB environment, and then you turn this knob to maximum, it should show the maximum value, which should be, if you connect this chip to the 3.3 voltage on the Raspberry Pi, the maximum value should be then 3.3 voltage. So then by turning this knob back and forth, you will see that the voltage signal that you retrieve in the MATLAB program will be changing from 0 to the maximum, which is 3.3 voltage if you connect it to the 3.3 voltage source on the Raspberry Pi. So here you see the final setup for this example. So I have the Raspberry Pi here, I have the general purpose input-output connector here. Here I have this analog to digital chip, this MCP 3002, which is connected to the proper pins on the general purpose input-output connector. Then I have this potentiometer here, also connected to the proper pins on the Raspberry Pi, and it's connected to these input channels here on the analog to digital chip here. And then by turning this knob from minimum to maximum, I should retrieve a voltage signal within MATLAB from 0 to 3.3 voltage, because the positive pin here is connected to the 3.3 voltage pin on the Raspberry Pi. So let's see how we can create a program in MATLAB in order to make this happen. So here you see a basic example. You want to start to establish connection with the Raspberry Pi device. Then you need to start communication with the SPI interface like this. Then you need to start write and read data to the component, in this case this analog to digital converter chip. And I will not go into all details here, but typically you need, when you are using and connecting to a new component, either it uses SPI or I2C, you typically need to carefully read the datasheet that comes with that specific component. Because in the datasheet you find all the necessary information in order to create the necessary parts of the software that you are going to create in order to communicate with that specific component. But basically I use the write read command that is part of this Raspberry Pi MATLAB support package, and then we typically need to do some conversion and also and then we are retrieving the ADC value, which is typically a value between 0 and 1023, because this is a 10-bit. This ADC chip has a 10-bit resolution, so the value will be between 0 and 1023. And then we need to convert it to a voltage signal using this specific formula. And since I have connected it to the 3.3 voltage pin on the Raspberry Pi, I need to divide 3.3 by 1024, which is the number of levels from the ADC chip, and then I multiply with a specific value, and then by that specific formula I will be able to get the specific voltage value, and then I can use the disp in order to display the voltage value to the screen. And typically a normal practice will be here to clear the objects created here in the beginning. So basically that's the entire program that you need to create in order to be able to communicate with ADC and retrieve and display the specific voltage value. So now we are back in the MATLAB environment, and here you see the program I just showed you. I just copied it into the MATLAB editor, saved it as ADC_X like this, and then I can just run it. And now I have turned the knob on the potentiometer to max, and then I should expect a voltage of 3.3 to be displayed to the screen. So then I just clear all variables here and remove them like this, and start the example by clicking the run button. It will take a few seconds in order to retrieve the value, and you see here I'm retrieving now about 3.3 voltage. Then I can turn the knob on the potentiometer to the lowest value, and now I should expect 0 voltage to be displayed here on the screen. So then I just click run once more, and you see the retrieved value is 0. Now I can turn the knob halfway, so then I should expect something in between 0 and 3.3 voltage. Like this. So now I'm retrieving 2.8 voltage. So basically this is a simple program to retrieve one value from the ADC chip. Of course you can improve it by using a for loop like this. So now I can run this one, and then you see you will retrieve a voltage value. Now I can turn the knob to minimum, and then I increase it step by step, and then you see the voltage is increasing. Then I turn it to max, and it should show 3.3 voltage like this. So now I have used the knob on the potentiometer to change the voltage value that are retrieved from this ADC chip. So basically, by creating this basic program, you are able to communicate with the Raspberry Pi and the SPI interface, and then creating a simple for loop or a while loop. Then you can continuously read updated value that are connected to the ADC chip like this. Finally, in this tutorial I use a temp36 analog temperature sensor and connected to the Raspberry Pi, but since this is an analog sensor, I need to use this ADC chip in order to be able to retrieve the analog signal from this temperature sensor into the MATLAB environment. So here you see an overview of this temp36 temperature sensor. It's very easy to use and easy to connect. Typically use a breadboard and then connect it to the Raspberry Pi through this ADC chip. So it has 3 pins. Here is the voltage pin that you connect to the either 5 voltage or 3.3 voltage on the Raspberry Pi. Then you have ground, and then in the pin in the middle you get the analog voltage signal output, which is basically the temperature value. So then in order to find the specific temperature value in degrees Celsius, you need to look up in the datasheet for this specific sensor, and in the datasheet you will find this plot. And since we are using a temp36 B, it's this line. So here you see the relationship between the voltage output that comes from out of this pin and the relationship between this voltage output and the temperature in degrees Celsius. So there is a linear relationship between the voltage and the corresponding temperature. And then we can use or find the formula that gives the relationship between this temperature and the input voltage value. And the final formula will be like this: y equals to 100 times x minus 50, where x is the voltage value. So then you can just basically implement this basic formula in our MATLAB program in order to retrieve the proper temperature value in degrees Celsius. So here you see the final wiring for this example. I have temp36 here, I have the MCP 3002 duct device here, and then I connect the output pin on the temperature sensor to the input channel on the analog to digital chip, and then I wire the other pins on the analog to digital converter pin to the SPI pins on the Raspberry Pi like this. And then the application or the program will be very similar to the previous example. So the only thing I need to change is add this formula that convert the voltage signal that are retrieved from the ADC chip and converted to voltage. Then when it's first converted to voltage, I need to convert it to degrees Celsius according to this formula, which I found from the data sheet of this temperature sensor. And then I just display this temperature value to the screen, and then it goes into a loop, so I'm able to retrieve new temperature readings every 5 seconds. In this case, of course, you can change the pause here to 1 second, 5 seconds, 10 seconds, 60 seconds, etc. And also the same for the for loop. You can also use a while loop, or here I set just N20, so then this for loop goes from 1 to 20, and in each iteration it reads a new value from the ADC, convert it to voltage, then convert it to temperature, and then display the temperature value to the on the screen in the MATLAB environment. So now I'm back in the MATLAB environment, and here you see the entire program for this application. Establish connection with the Raspberry Pi, initialize communication with the SPI interface, and the for loop that are retrieving new values from the ADC through the via this retrieve values from the ADC, and we connect this temp36 to the ADC, so we are able to read ADC value, then we convert it to voltage, and then convert it to temperature in degrees Celsius, and then we just print it on the screen every 5 seconds like this. Of course, we could also add features for plotting the temperature values, etc. But let's just run this example. And then you see now the temperature is now 24.7, and then a new temperature is read from the system every 5 seconds like this. So basically this is how you create a basic application for retrieving values from an analog sensor like this temp36. And since this temperature sensor is an analog sensor, you need to use an external ADC, since Raspberry Pi has only digital pins available. So that's all for now. So let's summarize. We was introducing the Raspberry Pi and the MATLAB environment, and since we are going to communicate with the Raspberry Pi from MATLAB, we needed to use this MATLAB support package for Raspberry Pi, which you can download and install. Then we was able to communicate with the Raspberry Pi and use the general purpose input-output pins. And in this tutorial we was focus on using the I2C and the SPI interfaces. For the I2C we was connecting a TC74 I2C temperature sensor, and for the SPI we was first using this ADC MCP 3002, and then we combine this ADC with this analog temperature sensor. So basically this is how you use Raspberry Pi in combination with the MATLAB programming environment. So thank you and goodbye.